Welcome, folks. This is the St. Louis Linux Users Group meeting, Thursday, July 18th, 2024. The speaker tonight will be Craig Buchek, talking about software architectures, big and small. Up front, though, we have some discussion. Sean's going to show us the new website. But before we do that, Stan, why don't you run through our introductory segment?
Hey, this is a special interest group that's affiliated with the St. Louis Unix Users Group. They support us with all kinds of stuff. The agenda is going to be Central Standard Time, 6 o'clock on until 6:30. Arrival, you can test chat and microphones, your sound and screen sharing, things like that. And at 6:30, we start our introductions, announcements, sponsored meeting, archives, calendar, mailing list, and then we go to call to help. I'm Stan Reichart. I do production here. James Conroy is our chairman. Gary Meyer, a normal MC, may or may not be here later. Lee Lambert of Omnitech is our host. Would appreciate it if somebody monitors the chats as we go along. 5 days from now, fourth Tuesday is a new Linux meeting. The next Slack meeting is usually on the first Thursday. STLLUG general meeting is on the second Wednesday of each month. Sean's going to provide some talk about the alternate STLLUG and St. Louis web pages he's been doing. We have other sponsored meetings, the new Linux users group and the Slack meeting group. They deal with the beginner workshop and configuration workshop for the most part. We also have our archives. We record these meetings, the STLLUG meetings and the St. Louis Linux Users Group meetings, and they are recorded, and they are on each of our web pages. We have links to the presentation archives listings. We have a calendar system that, and all on the calendar, our sponsored events are highlighted in red, and you can. And we also have mailing lists, a limited announcement list. Usually just the instructions for the meetings are sent there. General discussion can be done on our discuss list. We have a steering committee list. And we also have a sysadmin mailing list, but it's only for volunteers that actually do any work for our staff, staffing our meeting. Then we can go into our call for help meeting portion. I think at this point, we should go right back into the announcement section. And Sean, you want to talk about your thing?
Yeah, sure. Thanks. Let me share my screen here. Appreciate it. So I've been working on a new website for STLLUG, and I've been talking about it a lot. And today I just want to do a quick little update on what has changed since last meeting, so like 8 days ago. Hold your questions to the end, so I'm going to try to get through this really fast. So the first thing that I added was the calendar on the home page. So down here, it's the exact same calendar. I literally copy and pasted it off of the existing STLLUG.org website. If you click this little open and new icon right here, it will take you to the full page calendar on Google. So that's that. The other thing is I added some new colors. So if you saw it last week, it was very gray, and I wasn't too happy with that. I've changed it to a lot more bluish, and to me, it looks a lot better. In addition to that, I have came up with this I think pretty slick dark mode. So now if you're one of these dark mode people, you can view the site in dark mode, and it automatically switches based on your system. At least, you know, hopefully that works. We'll see. But yeah, it should automatically switch based on your system. So like I just changed my system to dark mode, and the website automatically responded to that. And, you know, I'm not good at picking colors or anything. Like, I don't know anything about that. So all I did was I pulled up the default dark and light themes from VS Code, and I picked a few of the colors they use and just put them on the website. Very easy to change this or whatever. Oh, and then the other thing is across the top of the nav bar here, there used to be a link for STL Linux and STLLUG where you could see those individual meetings, but I didn't think those were too useful, so I took them off the nav bar. You can still get to them from the About page, but I took those off in favor of this new resources link here. And on this resources link, I basically linked to all of this, a lot of the stuff from the old site. So like the attendance is posted on the old site, the handouts, the newsletter, the mailing list, the presentation archive, all this stuff is linking, just linking back to the old site. But I wanted the new site to be, somewhat, feature parity with the old one. So I put some links here, including the wiki and stuff. If there's something on the old site that you use, on the existing site that you use that's not here, let me know and I'll copy a link over to it. Or if some of this stuff is so out of date we don't want it on the website anymore, like the handout or the newsletter, we can remove that too. It's all this stuff is very easy to change. I also added some stuff to the About page. So I added this socials section here where I put all of our all the group social media stuff. You might notice that this is new from last week, but we now have a Mastodon account as well as a Twitter, and I'm cross-posting our meetings to both of these. And when I upload like the YouTube videos or the recordings to YouTube, I'm posting about that as well. So if you're on Twitter, please follow @STLLUG.org, or if you're on Mastodon, @STLLUG_org, @mastodon.social. Please follow us. Please subscribe to the YouTube. That helps us with the algorithm. All right, and then I also added this contacts, departments, and mailing address. I don't know if this PO box is still a thing, but it was on the old website, so I kind of ported it over. I also did some work so that our links show up all pretty like this. So this is where I posted that I was excited for the presentation, and I included a link to the site. And as you can see, it has like the title, the presenter, and then our image all pretty in the preview. But here, if you look at like Meetup, for example, Meetup doesn't do it as well. Like, yeah, it has the title and the whatever, but it doesn't have the image. So we got a leg up on Meetup that way. And these previews should work on like LinkedIn, Facebook, Twitter, Mastodon, whatever. A lot of these social sites kind of all use this thing called Open Graph. And so theoretically, if you post a link to the new site on any of those, it should show up in this pretty preview. And I think that's it. I think that's everything I've done since last week on the site. I think it's pretty good now. I think it's pretty feature complete now. At this point, I think it's ready to become the main site that people see when they go to STLLUG.org or STLLinux.org. So I'd like to discuss that at the next SteerCon meeting. So if you don't want that to happen, let's have that discussion either on the SteerCon mailing list or the SteerCon meeting early next month. But I'm definitely gonna be bringing this up, that we should make this our main site soon, at that meeting. And also, if you know any other LUG organizers that want this or a website like this, have them go ahead and reach out to me or reach out to steercom@STLLUG.org, and I can help them, because this is all open source, so they can fork the repo and I can help them get up and running with having their own site like this. I think it'd be very easy to port this over to any other type of user group or anything like that. And that's it. Hopefully it wasn't too much more than 5 minutes, but that's what I got since last time. So thanks for your time and attention. Appreciate it.
Looks great, Sean.
Yeah. Are there any other announcements from anybody? Okay. Oh, guess not. I see Craig has joined us. Are you ready? Yeah.
Are we doing a call for help? Anybody have a problem that we can solve? Hopefully it's something related to computers.
Um,
I'm watching the chat and I don't see anything there, if that's what you're looking for, Stan.
yeah. It's, okay, I guess at this point we should go into
There he is.
Craig's. Yeah.
Well, for anybody who's been here for a while, Craig Buchek, old member of the group, been around for years and years and years. He actually got me started in Ruby about 15, 20 years ago, Craig. And he jumped ship, went to San Francisco, and he's been doing his thing out there for what, 6 or 7 years?
Each for 4 years.
4 years, okay. Well, anyway, Craig, I will turn the floor over to you so you can tell us about your presentation.
All right. Hi, I'm Craig. I'm going to talk about architecture, design, and patterns. Welcome to my coworker, Mikhail, not from St. Louis. He is from North Carolina. Actually, he's originally from Ukraine. So welcome, Mikhail. He's been my main coworker for the past 2 years, actually. So
hello, Craig.
Thanks for showing up, Mikhail.
Hello, everybody.
All right. So this is a talk I am giving at Madison Ruby Conference in 2 weeks from today, I believe. And I have been a member of the St. Louis Linux user group since 2001, I believe. So yeah, I've known a lot of you here for a couple decades. So feel right at home with this group. So this is from Madison Ruby. If you want to @, me, my Twitter handle and my Mastodon on Ruby Social are Craig Buchek. I don't have this short URL already, and I don't have the slides online yet, but hopefully I'll have them and share that on the mailing list. Let's see. I think we're ready to go. If you have questions, feel free to just unmute and just holler out. I don't really have access to see who has the hand raised or chat or anything like that, because I already got 2 screens full of the presentation and my notes. So just holler out, try to wait till I'm getting to the end of a slide or a sentence or something. That'd be great. I'll try to remember at the end of each slide also to ask if anyone has questions. So start off with, I have questions for you. So you can unmute and you guys can answer in the affirmative for anyone that can. So who's familiar with this book, Design Patterns? Anyone?
I think I remember it from college, or at least seeing books like it.
Yes. All right. Does anyone remember that there was a companion CD you could buy? I did not. Even though I own the book, I don't know if I own the CD or not. But in my research, and it turns out when you give a talk, you're the one learning more than anyone else. So I learned this. There's actually a Ruby version of the book. And is anyone familiar with this book?
Nope.
All right.
No.
So this will be new to a lot of you. So I actually own a copy of this book. And a lot of the presentation is based around this. So my agenda is to talk about software design patterns, their history, where they came from, and their history coming from building architectural patterns. I'll talk a little bit about pattern languages and figure out some things we missed and talk about architecture in the small. So software design patterns. A design pattern is like a general solution to a common problem. It's not an algorithm. It's not that specific. It's not specific code. It can't be copied and pasted. It's more like the blueprint of an outline of a solution. Does that make sense? I'll have some examples here in a bit. So patterns help us use a common language to describe these solutions to these common problems. And so our patterns usually break down into a couple different pieces. So we have the name of the pattern. There might be some aliases. The intent is what are we trying to accomplish? And we're trying to accomplish those within a certain context. So the context is the conditions under which the pattern works well. And then we've got a problem. And the problem is we're trying to reach some goal, but we've got constraints. Like all engineering, right? We've got competing constraints, and we need to figure out how to get a solution that meets all those or balances them well. And our solution is going to balance those system of forces. And of course, we're going to cross-reference because a lot of these design patterns depend on other design patterns or reinforce or are similar. So we'll see these. I'll show some examples shortly. These are some names of some design patterns, some software design patterns. So a singleton is a class that can only be instantiated once. So you can only have a single thing of that class. A factory is a class or method that creates objects. A strategy is a class that provides an algorithm that can be swapped up for another algorithm. So in the context of Linux, you might have different thread scheduling or process scheduling. At a certain point in time, you could there were a couple different strategies, different algorithms you could swap in for your threading or process task switching. A template method provides a default implementation that can be overridden. The visitor pattern we'll take a look at. It's used to iterate over a collection of objects. That's pretty common in a lot of languages. And a null object is used to provide a default implementation that does nothing. And I just happened to give a talk on the null object pattern at a conference about a month and a half ago. That's why I added that one. All right, so actually I am going to go show the null object pattern. If I can find it. Okay, this is one website's version of a patterns catalog. So we've got the null object design pattern here. The intent is to encapsulate the absence of an object by providing a suitable alternative that offers suitable default do-nothing behavior. So we should use it when we require a collaborator, but that collaborator really shouldn't do anything. So we got a problem statement. Yeah.
Would it be fair to liken a null object to the concept of zero in math?
Yes. Yeah. So zero is a null object if you are adding.
Right.
So let's say you've got an addition function and you've got number 10, but you want to add different things to it. So if you've got 10 and you add 1, you get 11. But if you want to add nothing to it, you would pass in 0. 0 would be your null object for addition. And so depending on what your algorithm or your behavior is, you're going to have different null objects actually. So for addition, 0 in fact is the null object. So then we have a discussion about, okay, how does this all work? And we usually have some diagrams of the structure. So in this case, we've got a ball, and it's using the strategy pattern here, which I'm not sure why. That's just complicating things, I think. But we could pull in the no ball motion strategy. When you tell it to move, it just doesn't move because you probably don't actually have a ball. It's probably the null ball. So if you don't have a ball and you need to pretend like you have a ball, we'll use the null ball or the null ball movement here. So here we've got basically an abstract object. So I guess that would be a ball, and then we've got a real ball, and then we've got a null ball that does nothing when you throw it. So the structure there, and then some pointers and tips, and usually there are some links to other patterns. Am I ready for this one yet? No. All right. Let's see, should I get into? Actually, I'm going to get into this one. This is from actually that blue book I started with. This is the iterator pattern, and it is to access the elements of an aggregate object sequentially. Actually, it also might be known as a cursor, and this is pretty long. But say you have a list and you want to iterate through the list, you can create this other object that can get the first thing, the next thing, and tell you when you're done. Which seems all very complicated because it kind of is, and I'll get back a little later. So the point is, we can have an iterator for a list, but we can use a similar iterator for, I guess it's not in here, for trees. So we can abstract this iterator idea to lists or arrays or maybe hashes, trees, graphs, kind of anything that is an aggregate object, actually. And so I don't think it's here, but I saw, if you remember your college things about trees, there's pre-order, in-order, and post-order traversals, which means that your tree has a parent and it has children, and if you're going to traverse it, do I start with the children first, or the left children, or do I start with myself first, or do I start with the right children? And so so in order would be the parent comes between the left child and the right child if it's a balanced tree. Otherwise, it's pre-order means the parent goes first. Let's see what else is interesting in here. Applicability, multiple traversals, right? That's nice. So we can actually we can iterate, have two iterators for the same object, which isn't very common in programming languages that have built-in iteration. And it's a uniform interface. So if you're in Java and you see this, an iterator, you'll kind of understand what that means. So here's the participants, collaborators, and like I said, variations in traversals. So we might have that in order or post order of a parse tree. They simplify the interface, and it's repeating itself there. So here's an implementation. This book is a lot in Java and C++, but it does talk about Smalltalk and Common Lisp object system. So this is, let's see, how many pages is this? This is quite a few pages of just this one pattern. So we started on page 277 and 282.
257.
And we're still going. So there's a lot to this. Wow, there's a lot to that. So it looks like we're like 12, 15 pages in. So here's the end of it. So related patterns, we have cross references here. The factory method, we might use a factory method to create an iterator.
I've never done that.
Let's
The
see.
use case, I think, for writing your own iterator. Have you ever used this in practice?
Yeah, well, I don't usually write my own, and I'll get to why that is in a couple slides, actually. Let's see. We got examples from Buchek. I'll talk about him in a bit. And actually I get there. So basically, here's a bunch of examples. Here we've got the list traverser in, this appears to be Java. So yeah, examples. Any questions on this? Anyone want to dig in any closer to any part of this?
So in Java, the lists are very weakly typed, I think, or like they're strongly typed about what objects you can put in the list, but then, all bets are off when it comes to mutating those objects from inside the list or replacing objects inside. And so sometimes I feel tempted, like maybe I should create my own list class here. That way I know that people aren't changing out these objects on me or adding additional ones, like, because sometimes you want like a fixed size, and I don't, anyway, I've thought about doing this, but then it's always like so much work and it would slow me down. So it's okay. I'm just gonna use a normal list.
Yeah, so here's an example here. They've got a list, but it also has a skip list. And so you can have an iterator for your list and an iterator for your skip list, and they should actually have the same API. They should work the same. They don't really care if that list behind it is an array or a vector or a single linked list, double linked list, or a skip list. That make sense?
Yep.
All right. All right. I think that's enough on that guy. All right. Continue on. So we've got these software design patterns, and they tend to fit into 4 or 5 categories. So we've got creational patterns, which create objects, like the factory pattern. The factory pattern is specifically to create objects. So structural pattern is a way to organize your classes and objects to form larger structures. Behavioral patterns provide communication between objects. So the null object pattern is a behavioral. So you want to have this thing behave as if it's nothing instead of something. So concurrency patterns, pretty clear, those deal with multi-threading, multitasking. And then architectural patterns deal with the high-level structure. And a lot of people don't actually put that as a separate thing. Those usually end up in structural. We'll talk a little bit about that as well. The first problem with design patterns is that many developers misunderstand patterns, what their purpose is, and how to use them. So you'll often see a junior developer trying to take the patterns they know and apply them to every problem, even though they don't fit that context. Instead of thinking as these are tools that I need to plug in everywhere, I like to think of them more as a common language to describe the solutions to common problems. Before iterator had a name, people were probably using it a lot and probably using it in similar ways, and they kind of figured out, hey, this is probably the best way to do this, at least in this context. And so they started writing these things down. They probably started writing them down before they even called them patterns. So one of the other problems with patterns is you can't really reuse a pattern. You can't reuse the code for a pattern. It's more like we apply this pattern, and it's going to be different depending on what code we're doing. They're also they are not. Oops. Where are we at? So they're context dependent. They're not very reusable, and components. The thing we've been waiting for I don't know, 40 years it seems like. Components are a better way to reuse code. I guess React gave us components, but I'm not very happy with them. So many of these patterns are paradigm specific. And you'll see almost all these original patterns were object-oriented, and nobody really touched functional programming patterns until much more recently. So they're paradigm specific. Many times they're language specific, and I'll get into that in just a bit. And they're not a substitute for experience. Like if you have experience, you're usually going to sort of internalize these patterns. And to me, the important part of is you've already internalized is to make sure you use the proper name so we can communicate with other developers more easily. So we're using the same language. So many patterns are just a replacement for missing language features. For example, in machine language, we had a pattern called subroutine. But now we don't think of that as a pattern. That's just a language feature. You would call a function or you call a method. In Ruby, we have an enumerable API, so we don't need the iterator or the visitor patterns very much. Most of the patterns in the Gang of 4 book, which I'll get to in a second, are object-oriented. Let's get into some missing language features. So the top is in Java, and we are using an external iterator. So nodes is a set of nodes. We don't know here. Maybe it's a list, maybe it's an array, maybe it's a vector. But we get its iterator. We create an iterator for it. And then while it has a next item in that iterator, we hit next, and then we do something with that node. But in Ruby, we don't really need an external iterator because we have this built-in each. In some ways that's an iterator, but it doesn't need to be a separate thing. It's just a method call that we pass a block to, and a block is really just an anonymous function. So whereas in Java we had to do 4 lines, in Ruby we do 1 line, and it doesn't feel like a thing because there's nothing special about it. There's nothing outside the language features. That makes sense? Any questions? All right. So design patterns, where did they come from? So this is the software design patterns book. It's called The Gang of 4 book. Eric Gamma was the lead author. So sometimes we call it Gamma et al. But usually we call it The Gang of 4. It covers 23 patterns, only 23 patterns. It's a fairly substantial book, but you saw how long each of the patterns took there. They're mostly in Java and C++, and they're language agnostic-ish. Like they apply to pretty much the languages, the object-oriented language that existed in 1994 when it was released, but not so much with newer languages, not so much with functional programming. There might be a few that apply, but not too many. So this is Eric Gamma. He's a Swiss computer scientist. In 1988, he started on his PhD, and he started applying the idea of design patterns to software engineering. He also co-authored the JUnit book with Kent Beck. He worked for IBM Rational. He worked on the Eclipse IDE, which before that was Visual Age IDE. And he's actually worked some on Visual Studio Code. There are no individual pictures of Richard Helm. That's him on the right there. He's an Australian software engineer and consultant. He's into software architecture, object-oriented design, and IT strategy and IT transformation. So he doesn't seem to be quite in the software realm as much as he was back then. This is Ralph Johnson. He's an American computer scientist at UIUC. Some of you may have gone there. He was a major contributor to the development of object-oriented programming and Smalltalk, actually. You'll hear Smalltalk a lot in this talk. This is John Wilsides, an American software engineer and researcher. He worked with Stanford University and IBM Watson Research Center on software design and development, software visualization, design tools and techniques, application frameworks. And has anyone here ever used Interviews, which was like a competitor in the early X11? He was involved in that UI toolkit. Let's see. So the forwarder of the Gang of 4 book was Grady Buch. The year before that, he had written the book Object Analysis and Design with Applications, which is explained the Buch method. He probably coined the term object-oriented design. He was heavily involved in UML, the Unified Modeling Language. He also worked at IBM Rational. Before UML, we had the Rational Unified process, which is use case driven, architecture centric, and iterative and incremental. So this is 1993. Well, I guess RUP was after 1993. But this incremental and iterative is very much in the agile camp. I believe he's now at IBM Research as the chief scientist for software engineering, and he's working on a book called The Handbook of Software Architecture. Also, apologies to Grady Buch because on GitHub, I ended up with the Buch handle and he did not. And that's my last thing that's Booch instead of my full name. All right. So prior to the Gang of Four book, there was a community of people who were already using patterns. The Gang of Four themselves, Grady Booch, and I'll get into some of the others in a sec. So this is the C2 wiki. C2 stands for Cunningham and Cunningham. We'll get into that. This wiki was designed for the design patterns community to talk in the I don't actually have the date here, mid 90s, maybe even late 90s. Part of it was called the Portland Pattern Repository of People, Projects, and Patterns. And Cunningham, which we'll talk about in a bit, lives near Portland, Oregon, so that's why it's Portland and Cunningham. So this is actually the very first wiki. He called it Wiki Web. And Cunningham himself wrote that software to be used for collaboration. Let's see, is there anything? Nah, okay. So 1995, year after the Gang of Four book, Jim Copline released a conference set of papers called Pattern Languages of Program Design. I actually knew Jim Copline from his book on C++, Advanced C++ Programming Styles and Idioms. So I was actually surprised to see him in the patterns community. I thought he was more of a C++, but it turns out a lot of these folks involved are involved in a lot of different things. All right, so Ward Cunningham. Who knows Ward Cunningham? Anyone know who Ward is? How many people know who Ward is?
I've heard the name.
All right.
Is he the
You
one
should have
that
heard the name a
got
lot.
the
You will hear
bulletin
name a
board
lot.
system? Was he the guy from Chicago?
No.
Okay.
Nah. You'll probably
That's
get.
the
So
first
he invented the
BBS.
wiki. There's another person that's related to the first BBS, sort of. We'll get to him in a couple slides. So Ward was involved in a lot of stuff. He was involved in Smalltalk, the Eclipse Foundation. He's a signatory to the Agile Manifesto, which was 2001. The Framework for Integration Testing. That is a testing framework. Pretty cool, actually. Extreme Programming. He probably coined the term technical debt in 1992. If you are old school object-oriented analysis and design, you may remember the CRC class responsibility and collaboration cards. He invented those. He invented the wiki, and more recently the federated wiki, which is sort of a forkable wiki, which kind of blows my mind. And he's also known for Cunningham's Law, which says the best way to get the right answer on the internet is not to ask a question, it's to post the wrong answer. And the funny thing is, Cunningham says that is the wrong answer. It's not actually, he was not the original of that. So Ward, along with Kent Beck, who's the next slide, wrote a paper on graphical user interfaces in Smalltalk in 1987. So they preceded the 1993-1994 Gang of Four book by quite a bit. So they were involved in this earlier. And Kent Beck. So today I learned that Kent Beck was actually at Apple around this time. He would go on later to develop extreme programming, test-driven design. He also signed the Agile Manifesto. He wrote JUnit, and he was another Smalltalker. And I'll talk about a book in a bit. One of the sayings that I like is make it work, make it right, make it fast, in that order. All right, another person involved was Martin Fowler. 1999, he wrote a book on refactoring. He wrote the book on refactoring with Kent Beck. Currently, and for a long time, he's been the chief scientist at ThoughtWorks. 2002, he wrote a book called Patterns of Enterprise Application Architecture. He's written books on domain-specific languages, UML, continuous integration, and microservices. So this is his book. So the first book was 23 patterns, the Gang of Four book. This is 42 patterns. And these are targeted at larger systems. So there's not, I don't know if there's any overlap. If so, there's minimal overlap. And when DHH, the author of Ruby on Rails, learned patterns, he read this book and he applied them to Ruby on Rails. So Ruby on Rails actually uses the active record pattern and the model view controller pattern that actually came from this book. And I do not have that one. Nope, I don't have that. Hold on. All right. Okay, so where did the idea for these design patterns in software come from? Well, it turns out they came from a book about architectural design patterns. So this book is by Christopher Alexander. He gets mentioned a lot in the history of these software design patterns people. So this book is called A Pattern Language, and he gets into towns and buildings and how to construct buildings. And does it is a series of patterns, just like the software patterns books. And I'll show a little bit of that in a bit. So oddly enough, Christopher Alexander had been working since the mid to early 60s on architecture and trying to get to the philosophy of architecture and like, how do we make decisions? So he'd been talking and thinking about these things a lot, working on them. So this book is actually it's part of a 3-book series. Oddly, they released volume 3, then volume 2, then volume 1. I don't understand how that works, but that's what they did. Volume 3 was the Oregon experiment in 1975. The University of Oregon, they applied Alexander's ideas to campus community planning. And this Oregon experiment was sort of the test bed of the ideas in the later 2 books. It's very people-centric. His philosophy is that feeling should be the primary criteria to use for making changes to somewhere, to a place or a building, and that people can and should be involved in the design process of their spaces. So that resulted in a theory of architecture and planning, and that led to the 2 other books. So the second book was the Pattern Language, this book, which we'll get into more. This is the book we're going to focus on. And then volume 1, 1979, whereas this book was 77, is A Timeless Way of Building. And this is more of his philosophical approach, whereas Pattern Language is more about details, more not quite concrete, but somewhere in between abstract and concrete, whereas Timeless Way is more about the abstract. And the Timeless Way introduces the concept of the quality without a name. And we should seek to include that nameless quality in our buildings. So I was actually surprised that this book is a little more out there, a little less, I'd say he's a bit of an iconoclast, actually. So it's interesting that this iconoclast kind of, his ideas, or at least the way he expresses ideas, got taken from architecture to software. So this is Christopher Alexander. I believe he's still around. I think he's like 85 years old. He designed and personally built over 100 buildings as an architect and a general contractor. A lot of the way he describes building buildings is things that have been thousands of years, how people built their own buildings before we had builders as a separate thing. He is British American. He was at UC Berkeley for a long time. He did die a couple years ago. Let's see. He's got other books on architecture, another 4 series of books called The Nature of Order. which seems really interesting because it gets sort of in beauty and life and how we need to focus on those things when we're doing our design. All right, so a pattern language. So the book is called A Pattern Language. So what is a pattern language? It's a collection of patterns. It describes the problems and the solutions, and it's organized in a coherent way. And it's specific to a field of expertise. So in his case, it's architecture of buildings and towns. So Ward, Cunningham, and Kent Beck had been introduced to this book, and they're like, that would be a good way to talk about our patterns, this design pattern language. Who knows about this book? I'm guessing
I remember that.
At least 3 of you. Yes. Phil, you remember
Yeah.
this one?
Yes, I do.
All right.
I've
All
heard-
right. So, all right. So Stuart Brand wrote this originally in 1968 to 1972. Stuart Brand, this person comes up a lot in computer history. He started in the early 60s doing LSD studies. He was actually there at Douglas Engelbert's Mother of All Demos in 1968. I know Scott Granneman has talked about that several times in this group. 1984, he founded the first online community called The Well, which is the Whole Earth Electronic Link. He worked at Stanford, MIT Media Lab. He probably coined the term personal computer. The first printed use of it was from him in 1974. He was a director of the EFF from 1990 to 94. He founded the Long Now Foundation. Has anyone heard of that one? They've got the 10,000-year clock that they've built. They're working on a 10,000-year library. And now they've got something called Long Bets, which is like, in the long term, this will probably be true. How do we make a bet about that? And a couple other people, oddly, in the Long Now Foundation are Brian Eno and Esther Dyson. So another little tidbit here. In 1966, he posted, and he had buttons printed up to where, why haven't we seen a photograph of the whole Earth yet? 1966, NASA had sent, spaceships up to Earth orbit or even maybe to the moon by that point, I guess. But we didn't have any real good pictures of it until a year or two later. So he's credited with possibly pushing NASA to accelerate giving us good color photographs of the Earth from space. And the ecology movement takes shape a lot in response to seeing the Earth from that vantage point. So Stuart Brand gets involved in the story by 1994, writing a book, How Buildings Learn, What Happens After They're Built. So this was inspired by Christopher Alexander's work, and he extensively spoke with Christopher Alexander. There's actually a 6-part TV series for the BBC from 1997 with music by Brian Eno. So his theory there, well, actually, he's got quite a few things he gets into here. But he says the best buildings are made from low-cost standard designs that people are familiar with and are easy to modify. Another tip he's got is use materials that smell bad when they are wet. So you know when you have a leak. I'm like, that's brilliant. And like, how do we apply that to software design? I haven't quite wrapped my head around that one. But we do have sort of, well, I guess we log things. We log more noisily when things break. I guess we have layers. So when you do hit that boundary, you do have observability to tell when there's a leak. So all those things apply to software as well. I don't know if Stuart thought about this at the time. Oh, whoa, I'm out of sync here. Hang on a sec. Okay. No, that did. Okay. All right. So all those ideas apply to software as well. incremental change. What's a suggestion? Learning as you go. Choose the option that gives more options in the future. That is a huge part of what we're trying to do in software design to be maintainable. Because we have to admit that we don't know how this house is going to be used. We don't know how this software is going to be used completely. We're gonna have to worry about maintenance. He says that maintenance, let's see if oh man, these are out of sync. Hang on a sec. I need to do something weird here. All right. All right, I think that'll work. Okay, better. It says buildings are predictions and all predictions are wrong. So we should design so that it doesn't matter when we're wrong. He says a building is never finished. In fact, I didn't really talk about this yet, but I should get into this. So the left picture on this cover of his book is the original 2 buildings that are shown in current time on the right. And you can see they've evolved differently. And unfortunately, I just discovered this book or rediscovered this book like a couple days ago. So I haven't gotten into everything that I might want to talk about, but my presentation in 2 weeks is only half an hour, so I can't get too far in it. So he talks about the different layers. They're called shearing layers after a person named Shearing. And he's got these layers of the building. So first is the site of the building. And the site doesn't change a lot, right? And then there's the structure. There's the foundation, the load-bearing walls, the outside walls. They don't change very often. And then outside of that is the skin. So maybe the insulation, the windows, those get changed every 20 to 50 years because, hey, maybe we find better windows, better insulation, learn how to make our homes more airtight. And then you've got the services layer, which is interesting because we call it the services layer also in programming. And this changes more frequently in this. And, you're upgrading your electrical box, you're putting some Ethernet in, and those change, pretty much you're going to make some changes probably every decade or so. And then you've got your space plan, which is your interior layout, the interior walls, floors, doors. And these change. Sometimes we change out our flooring probably every 20 years. But the interior layout, we tend to do that probably more like 5 to 10 years. And then inside of that is all your stuff. So shearing layers are site, from the bottom up, site, structure, skin, services, space, and stuff. So he also says we shape our buildings and our buildings shape us. Adaptation between buildings and users is a slow and continuous process. But over 50 years, the changes within the building cost more than the building itself originally cost. I remember anytime they do some reconstruction on, especially like a theater, I remember when they did the Fox Theater in St. Louis, and they did the, what's the theater downtown next to the arena called? I remember they redid that, and it was amazing because those renovations cost more than the building originally. I'm like, well, that's crazy. So he says over 50 years, the maintenance costs will generally be about 3 times the cost of the building for a commercial building and 6 times for a residential building. So his advice is hire good builders and save money in the long run. Because if you can extend that to make it more maintenance free, it's going to save you a lot more money than it's going to cost you. He says that temporary is mostly permanent. So how many times you can think of a temporary workaround or a temporary thing in your home that's been there for years or decades, right? He says fail small, early and often, and you will succeed in the long run. A couple more things. A new building is a bad teacher of maintenance habits since deferring to maintenance is a habit. A building that has been maintained for a long time is a good teacher since its maintenance is a habit. So in many fields, architecture means like the unchanging deep structure. But Brand here shows us that there really is no unchanging structure. So I like to think of architecture just as structure, not so much as unchanging. It might be harder to change. I guess it might be an argument. Does someone have a question or comment? All right, Grant says there's nothing as permanent as a temporary solution. All right, anyone else?
Yeah, I was about ready to say, when you were talking about the amount of maintenance is about 3 times more than the building, made me think of the Mythical Man Month by Brooks.
He is right in the center of design, for sure. So yeah, you're talking about the Mythical Man Month. And let's see, I don't see me. Where am I? The Mythical Man Month, Fred Brooks. He also has a book called The Design of Design. So kind of gets into this topic as well. So there's all these threads of different people in different communities that kind of all get together and share ideas. It's an amazing thing that happened. So we think of architecture as big, we think of buildings, we think of cities, we think of software systems. We can also think of small architecture, like rooms and software components. My wife happens to be an interior designer. She has a degree in interior design. And some programs actually call that interior architecture because it's the architecture of the small. And that's another reason that I kind of with architecture, because it's related to her field. Ironically, this is one of my favorite books, on one of the best books in my opinion on Ruby, even though it almost came out before Ruby came out. It turns out the Smalltalk and Ruby are very similar, so most of the things that apply to Smalltalk apply to Ruby. A lot of these actually are smaller patterns that apply to almost any programming language. So I want to get into that, some specifics here. Oh man, go away. All right, you go. I can't do that. Okay. Let's see. Okay. So this is Smalltalk best practice patterns. This is a pattern called intention revealing selector. And a selector is the name of a method. So and in any other language, you would call this an intention revealing name. And I have, Mikhail has probably heard me say, and I want something intention revealing. So we are trying to name a method, and well, here's the question: what do you name a method? The first is to name it after how it accomplishes its task, and the second option is to name what it's supposed to do. And we don't care how a method does something; we care what it does. That's kind of the whole purpose of a procedure or function or method. It's to not care about how it's done. Like let that method, that function, that procedure, let it figure out how to do it. I just want to tell it, hey, do that. So when I tell it to do that, I don't want to tell it how. I just want to tell it do that. So name methods after what they accomplish. So his patterns are a little bit different. So here's the cross references here at the top. That's kind of probably a little early. Oh, actually, he might have some at the top and the bottom. Yeah, he does have them at the top or the bottom. So the ones at the top are ones that came earlier, actually, most likely. They are patterns that this pattern builds on. And the ones at the bottom are patterns that build on this one. So he just talks about how to name a method. So if I'm searching for something, just say search or search for. Don't say, linear search for or tree search for. It shouldn't matter in those cases. Try to name it after what? Oh, did he change? Oh, so he changed search for to includes actually. So yeah, I just wanted to cover one of those. That's a very small thing. Like your program, your method names, your function names, your procedure names, subroutine names in a program, like they're a very, very tiny part of your program, right? Like they're usually just a few characters out of, you know, how many thousands of lines of code. And yet he's thought about a pattern on how to name things, name our methods and functions. I thought that was pretty amazing that he really gets down into the nitty gritty with his patterns. And I found this book to be pretty amazing. Yes. Mikhail says the most difficult task in programming is naming things. I believe the quote is the three hardest things in programming are cache invalidation, naming things, and offline error. Although that last one was added on later. I actually got a book. What did I do with that book? There's a little book I just read probably 6 months ago. It's an entire book on how to name things in programs. And it was like 120 pages, nice short book, but it very much got into that same sort of advice, but it actually dug down on what are the reasons why we choose a good name, or what makes a good name and what makes a good name, and how do we decide when there's counteracting constraints. Again, engineering, you've got constraints that pull you in different ways. How do we come up with a solution? So I want to talk about doorknobs. So I was actually surprised that Alexander's book didn't cover this, and I will actually get into some of his books, some things he did cover. I don't know if this is true, but my AI that was helping me write this says doorknobs were invented in 1878. Very hard for me to believe. But door levers are much older. And so we usually use doorknobs, but levers are becoming more common. And apparently, you know, a long time ago, levers were more common. So how do we decide which of these to use? I mean, there are patterns, there are reasons that we can choose one over the other. And I actually found 2 web pages that help me choose which of these to use. So they basically give you the patterns. So knobs have more styles available, and they go much more better with an older building, the style of an old building. And knobs can turn left or right. But levers are easier to use. And they can be used with when your hands are full. You know, you can use your elbow or something. You can use your nose if you want sometimes. Levers are easier for kids, disabled people, older people. Someone that might have arthritis might not be able to grip that handle very well, but they can push that lever down pretty easily. But levers can easily snag on clothing. So the advice is don't use levers in place of handles if you're in a confined space, because if you're in a confined space, you're going to be rubbing up against it more. So if you got a wide hallway, the levers, the handles are actually pretty good. Oop, I did it again. All right. So architecture of doorknobs and handles and levers. We have a similar thing with buttons in architecture. I claim that a button is an architecture.
Lost him. I don't hear Craig anymore.
I was wondering if it was me, my connection, but yeah.
His screen is frozen.
But we shouldn't have every button be different.
Craig, you had froze there for a second. Can you kind of back up and start over with?
Yeah, sure. I don't know why my Wi-Fi is good. So we rarely think of a button as an architectural element in our software, but an architectural element is anything that's part of the structure of that application or that building, if we're talking about building architecture. So we should choose the right button for the context that we have, right? There shouldn't be a single one size fits all button, but we also shouldn't have every button be different. This is, I believe, from material design buttons. And honestly, that feels like way too many buttons. Like I could see different colors. There's some button examples where you've got a primary button and a secondary and a call to action and maybe a tertiary, maybe a warning. But really, you should only have like 4 colors and maybe 4 shapes. These feel like we've got too many things going on here. So I don't agree that like these switches, sometimes I don't know when they're even on or off. I almost talked my way into an architecture position by talking about architecture in the small and like, how many different buttons has your team written? Like now it's not so bad because we can get these components from a component library, but until like 10 years ago, every team would write a different button and they work different and they made, you know, got a lot more code to maintain. Maintenance is the major cost, right? But it also makes the users like confused. How do I use this button? How do I use this button? Why does this button work different than that button? So, you know, we need to think about our context. We need to think about, well, when we're building architecture, we want to worry about context, but if contexts are similar, we want to have similar designs, similar outcomes.
And let's not get started on like which button, like is the cancel button on the left or the right? Is the okay button? I mean, oh my goodness. The conversations that I've been in that go on and on about which button goes on which side. Oh man, get me out of there.
Didn't IBM
So it's
a standard that they tried to have all of their programs adhere to? It was either the 80s or 90s. Yeah, cool.
Yes, I believe you're talking about this. Yeah, so before that, WordPerfect, like everyone had a different set of commands to open a file. And then IBM said, hey, let's standardize these. And I actually, even though I rarely use Windows or anything IBM related, I still have many of these hard coded. Like who remembers using cut, copy, paste as, you know, with the delete and insert keys with shift and control, right?
Yesterday.
Yeah, exactly. Tab will get you between fields and dialog boxes, and shift tab will take you backwards. The other one I use is the cursor movements, like a shift cursor movement will select, and then like I think an alt cursor movement will move by word. Maybe that's control. And then you can actually add them together and you can shift select by word or by sentence. All right. Oh, there we go. So before I hit the conclusion slide, I want to show some of Alexander's design patterns. And this PDF doesn't have the entire book. It's only got about half of it, so I couldn't show specifically the ones I wanted, so I had to go through and see. So this book was published in 1977, so the pictures are not great. Actually, I think I can make that a little bigger. So that's a little kid hiding in a little cove. Looks like they're playing cards. It's 2 kids now that I zoomed it in. And there's a little piece of wood over their heads. I'm not sure what that is, but let's go find out. Okay, so this is pattern number 203 in the Pattern Languages book. And it references some earlier ones. And he's talked about having playgrounds for children, how we should make children's homes different, how the rooms should be laid out. And we probably want to have thick walls because they're going to be noisy. So, so this is sort of his premise. Children love to be in tiny cave-like places. And then he's going to tell us, well, how do we create these? Some ideas on where to create these and how to create these. So here's an example. Here he's under the sink. Here he's under the stairs. Here he's under the table. because kids are going to make those places for themselves, right? So we might as well help them. So his rule is wherever children play around the house, in the neighborhood, or schools, make small caves for them. Tuck these caves away in natural leftover spaces under stairs, kitchen counters. Keep the ceilings low, like 2.5 to 4 feet, and make the entrance tiny. Fill the caves right into the fabric of the walls. So basically, those are follow-ons on. Okay, so we've decided to make this thing. How do we flow from there? So one thing interesting is, so the way he wrote his patterns, some of them like get 2 asterisks, and those are like, yeah, everyone should be doing these. The ones with 1 asterisk are like, yeah, you should probably consider these, and the ones with no asterisks are ones he's like, I'm just kind of spitballing here. So I thought this would actually have 1 asterisk, definitely not 2. But yeah, so some of the interesting ones that I didn't get to capture here, one of the more interesting ones was his research on how tall to make a building. And you know, he's actually got footnotes and sources for his reasoning. So he says not to make buildings taller than 4 stories. And a lot of that has to do with just, you know, not having buildings that are, you know, different sizes next to each other. But especially residential buildings, he says it's not good to be above the 4th floor. And the research shows that kids growing up on the 4th to 8th floor get outside half as much as kids on the 1st to 4th floor. That's just amazing statistics. So that means that those kids are not as socialized. You know, they're not getting outside, they're not getting exercise, they're not getting fresh air, but they're also socializing less with other kids. And so his thought is there's not a lot of good reason in most cases to make buildings more than 4 stories. So let's try not to make buildings more than 4 stories. Interesting thing there is I remember my dad, he was a construction worker. And I remember when he was a kid, when I was a kid, he told me, you know, look at all the buildings in office parks. They're almost always like 3-4 stories. It turns out there's another reason for that, and that is water pressure. It turns out that if you got an 8-story building, you've got to push a lot of water up to the top to put it in your what do you call the thing? The water receptacle that if the electric goes out and your pumps aren't working, the water will still flow due to pressure of gravity.
Reservoir.
Or a water tower. A water tower basically on the top of your building.
Yeah. Do you know when he made those statements compared to like mass adoption of elevators?
So this is 1977, so I would imagine that elevators were pretty common at that point.
Okay.
So there were some really interesting ones. And you know, this is a half-hour talk that I'm now 40 minutes into. So I know that this group has a little more time than my 30-minute slot. So I'll talk about a few interesting ones. He talks about alcoves instead of having rooms. It's almost more better to have alcoves. There's one about the marriage bed and how the marriage bed is different from like a teenager's bed, and he's got advice for teenager rooms, and in fact he says teenagers and older folks should sort of have an outbuilding on your property, like they should have their own wing of the house. I guess was it mother-in-law's entrance or mother-in-law's room, where it's like it's got its own entrance, but it's also shared space with the family. Yeah, so he gets into all kinds of architectural things. All right, let me get back to my conclusion then. All right. Uh-oh. All right, got too many windows. All right, there, I think we're synced. Okay. Some in conclusions. So we have patterns as a way to describe common solutions to common problems. And when we make a pattern language, that gives us a common language that we can use amongst our peers, or at least the people that are familiar with that particular pattern language. And Alexander talks about, he's like, okay, this is a pattern language. Like there could be other pattern languages even for architecture. Like you might have like a brutalist pattern language for architecture. You might have a pattern language for mobile apps versus web apps. So there might be different patterns in those different contexts. Architecture is about structure, and structure doesn't necessarily have size. And the funny thing is, when I start doing these presentations, I often think the conclusion is going to be one thing, but I find things and it turns out to be different. So finding that second book about buildings, changing over time, that's more like the conclusion I want to get across. We can't predict what our future needs will be, so we need to design that change and that evolution and that adaptation into our software, into our buildings. We need to learn, we need to make habits, and we need to recall that most of the costs are going to be in maintenance. And architecture is about people, how they interact with the space or the software application. We need to keep that in mind. And I feel like these people have kept a lot of this in mind, like they're trying to help us be better software developers and use our tools better. So I did show so some resources you can do. Source making, I believe, is one of the ones I showed. So oddly, there's this refactoring guru design patterns, and then there's source making, which appears to be the same thing by the same people, but a different design and different set of patterns. So it's very, very weird. All right. So the Hillside group still has a conference, the Pattern Languages of Programming Conference. Martin Fowler, he had that Principles of Enterprise Application Engineering. He also has an architecture guide, and he has some of the diagrams from his book online. The Wikipedia entries on pattern language and software design pattern are pretty darn good, actually. And this one I probably should have put earlier. This is a paper from 1987, the first known paper on patterns in software. It is, of course, Ward Cunningham and Kent Beck. I imagine some of you know Alex Miller. He has attended back in the day. He had a talk called Design Patterns Reconsidered. I haven't looked on archive.org, but the website is lost for now. Doug Lee wrote an introduction to Christopher Alexander for programmers, object-oriented programmers specific. Before we had the wiki, there was actually this FAQ on a mailing list. Last updated 2000. So this was before the wiki, before any wiki existed. Patternlanguage.com is a site that actually still exists for the book. And I will probably sign up for a $5 a month membership so I can actually get digital access to this book so I can copy some pictures out for the conference talk. Let's see what else we got here. There's this awesome design patterns. Okay. Let's click on it. There's awesome lists all over the internet of software things, and this is software and design patterns. So Like I said, we have general, but we have pattern languages for microservices and serverless and cloud. So yeah, serverless patterns. Let's take a look at some of those. So hooking up your client to an API gateway, a Lambda, DynamoDB, and we've got other patterns to do serverless. All right, and so I actually found a few patterns myself that I documented. This is a long time ago. I wrote this one. I called it a grenade. Basically, you're debugging and you want something to blow up. Instead of doing the right thing, you want it to blow up. So when you call it, it just blows up and throws an exception. And now you know where that object got called. So I found that useful, and I documented. Readable shell scripts is basically saying, it's really simple. Instead of structuring our code like this in a shell script, just have a main function first so that we can see the main function ahead of everything else. Very, very simple pattern. And then the very complex pattern there in Ruby. So yeah, patterns can be very simple like this. And we'll run into patterns, and Mikhail can tell you this. In our code base, we have patterns that really don't fit any other piece of software than the application that we happen to be working on together. So you'll see patterns everywhere, and try to find the good ones, try to document the good ones, and try to replace the bad ones with the good ones. And I am interviewing now. I'm interviewing 3 companies, so don't really need. But if anyone has a little work, let me know. Opportunities. So thanks. I appreciate you guys. And I would be happy to hear any feedback on how to make this better for a conference.
Hey, this is Stan. I would
Stan.
recommend that you put text on the photos of the people you're talking about. Put their name in that photo.
Okay.
And
cool.
I think that would make it better.
Yeah, and if I want to say, does anyone know who this is? I can have it without the name, and then I can put the name on top. Cool, thanks. Yeah, I think there's some ordering things that need to be a little bit different, but
you touch on a bunch of different things, and I'm thinking to myself, I want to, once you publish the slide deck, go through and reference some things. I almost feel like you might be at a point you'd benefit from something akin to a bibliography, whereas you mention something, but you can then later in your slide deck, like this thing and a 1 to 3 sentence, what this thing is commonly known for, might help people that are wanting to, they see an idea, something in your slide deck and want to research it later. Even if it's a person's name on the internet, you're going to find people by that same name, but maybe just some more context to help narrow down the search.
Sure.
Sorry, maybe.
Because Ralph Johnson was not easy to find. All right, would someone else say something there?
Well, I can say great speech. I enjoyed it. But I would say that it has a lot of about architecture and a little bit less about actual, software application of this architecture, which I enjoy it because I love learning new things. But maybe you need to give a heads up for people that it's not a speech about software architecture. It's a speech about architecture and software.
Yes, for sure.
But I mean,
the abstract actually does touch on that, but it didn't get to the Linux user group page, I don't think.
Otherwise, it was great. I really enjoyed the part with the children caves. Yeah.
Yeah, I do need to get a little more from the books onto the slides. And for the 30-minute version, I'm going to talk a lot less about the people involved in the history of all these people. But it's definitely an interesting, and I think this group is more familiar probably with some of those figures in computing history. Whew. All right, anybody else?
Yeah, Craig, could you maybe put in the chat or whatever that URL to Wikipedia on that IBM, those keyboard things or whatever it was?
Oh, yeah.
Yeah, I feel like we've lost some things as people have abandoned common user access. And one of the things that about Kua was they tried to impose that on DOS and Windows applications as well as mainframe applications and make how things behaved consistent. They wanted things to be repetition, and you didn't have to stop and think, how do I do this in this thing? It's just, I want to copy, that's Control C. I want to paste, that's Control V or Shift Delete or Shift Insert. And I know that Apple was known for trying to enforce that in their ecosystem before Windows started doing it. And it seems like a lot of the Windows environments or programs they're in were not necessarily aware of Kua.
There was actually a book on the Macintosh design interface, and yeah. It's actually, Craig, it's I think it's in the same article in Wikipedia about Kua that you already opened.
And for all of its annoyances and Java applications, they did have a consistent interface provided by Java across platforms.
Yeah, so Apple's is called the Human Interfaces Guidelines. I think it's still called that. And it says down here that GNOME and KDE are pretty well compatible. Of course, on a Mac, it's command instead of controls, so we can use our control keys in the terminal, which kind of makes sense to me. I kind of like that. So almost so if I select, if I double click a word, it selects it, right? And I could hit shift the arrows and select characters, or shift control and I can select by word. So a lot of these muscle memories on my fingers still work. And that's kind of, the Command C, Command X. A lot of those are Command Z for undo or Control Z. A lot of us have muscle memory for those for sure. Anything else? All right. Someone want to wrap up the meeting?
All right, anybody else have any questions for Craig?
I will say that my presentations will be here soon. I don't know. It might be a couple weeks before I get it up here, but I will probably have it here in a few days.
Do we want to throw up your current slide deck or not to the presentation archive?
Oh, yes, I'll see what I can do.
The other thing I was going to ask is, once you do upload it to either GitHub or your site, would you please send a message to Discuss saying it's there so people could go out and pull down the finished copy?
Okay, cool.
This is Stan. I'd like to make the comment that I'm of the firm opinion that developers for Android phones, they have to have a frontal lobotomy before they start working.
Which patterns are they violating?
Yeah, all of them.
So I didn't cover it. I should have actually mentioned it. There's something, the concept of anti-patterns. There are patterns that people think are good and turn out not to be good. They're usually worse than the alternatives.
It amazes me that so many of these systems, they expect you to figure out pinch and swipe and which direction and all this magical stuff, and there's no documentation hardly on any of this stuff. You just, unless you hear somebody else on a discussion group talk about oh, you do it 3 fingers swipe to the left does this or some screwy thing. Oh, it's frustrating.
It's intuitive. It's intuitive, Stan. Come on.
That is
Also,
not a damn thing in the world. It's intuitive.
Do
The
Android
nipple,
phones,
the nipple is the
Well,
only thing intuitive.
that's the exception. Yes.
do Android phones still have a back button, and it always works not as you expect?
Oh no, don't worry. That's going to get a lot better because they're doing some kind of AI back button coming very soon. So don't worry. Once they put AI on it, it's going to get all better.
Yeah.
Oh
I
man,
doubt
AI
it.
is good. AI is going to give us a lot of anti-patterns, isn't it?
Already has.
Ah. Oh man. I think AI is going to be big, but it's also going to be. It'll make changes. It'll make drastic changes to society, but it's not going to be as big as some people think.
Yeah, the biggest problem I see, I've been playing with ChatGPT a lot. It takes more work to dehallucinate the reply than the time you save in asking the question and getting the answer.
Sometimes, yeah. Sometimes.
Here's, I put the link to the hallucination I was talking about earlier in the chat.
Yeah, I'm not sure about math in ChatGPT. I think it's language model in the first. There is like a specific math models that should do better. So probably in the future they will have ChatGPT call the specific model. Like they have function calling now. So yeah.
Well, ChatGPT just looks for an average answer from all the writings, and we know everyone's bad at math, so just grabs the average bad answer.
That sounds about right.
I'm curious for my book on naming things. Did I give it to somebody? I did find my old James Copeline Advanced C++ book. It's funny.
Lee, you want to do a bookend here? Turn off the recording?
I can certainly do that if we're ready. Anybody else? All right, this has been the St. Louis Linux Users Group, July 18th, 2024. The speaker is our longtime member and evacuee to San Francisco, Craig Buchek, who is still doing his tech thing. He still hangs around and he's got some interesting stuff to talk about. His presentation was on software patterns, large and small, and how they relate to building architecture.